We've already introduced decimals, and now we'll look at how to add and subtract them. So remember back in sections 1.1 and 1.2, we were adding whole numbers, adding and subtracting whole numbers. And we did it vertically, and you just had to remember to line up the ones places, line up the tens places. Just make sure you're adding things that are the same. And it's exactly the same with decimals. And a nice way to see it is, if you line up two decimals, if the ones are lined up, then the decimal points have to be lined up. And so example 1, add these two decimals, 47.2 plus 9.94. All right, so this is not the way to do it. You see this 9 represents 9 ones, but it's under the 4. That's 4 tens. All right, this is the correct way. So just line up the ones, line up the decimal points. Here are the tenths. Here are the hundredths. And we can see, the decimal point of the answer is also going to line up. Okay, so these are everything's in a line, so that's easy. Also, a neat way to do it is to give the decimals the same number of places. So we see here this 9.94 has 2 places, 2 digits to the right of the decimal point. This only has 1, but we can add another place, just add a 0 here. Okay, so we just added this 0 just to so we can see clearly, more clearly, how things line up. Okay, and then just now you can kind of ignore the decimal points and just treat these like whole numbers. Whole number addition. 0 plus 4 is 4. 2 plus 9 is 11. Write down the 1. Carry the 1. So this is really 11 tenths. So that's 1 tenth, and 10 tenths, which is 1. So we just carry like in the usual way. 7 plus 9 is 16, plus the 1 is 17. Write down the 7, carry the 1, and 1 and 4 is 5. Okay, then don't forget to put in the decimal point, just line it up. So the answer is 57.14, or 57 and 14 hundredths. And just to go back and check that answer makes sense, in particular check that our decimal point's in the right place. So suppose you were, so if you kind of rounded these numbers, so this first number is close to 47, this second number is close to 10. So if you're adding 47 to 10, you'll get 57. Okay, so the answer makes sense. So something close to 47 plus something close to 10, you're expecting the answer to be close to 57. Okay, so you can always do that with decimals. So for example, if you had 5.714, you know that would be wrong. Your decimal point's in the wrong place. So yes, always, use common sense when you're looking at these. And subtractions done in the same way. Here, 47.2 minus 9.94. Okay, so 47.2 on top. Again, we can give this an extra place, so they both have 2 places. Add a 0. Yeah, let's go over here. Yeah, this is cleaner. So 47.20 minus 9.94. We're lining up the decimal points. The decimal point of the answer will go here. And now you can just treat this like a whole number subtraction. All right, so 4 from 0 doesn't work, so we have to borrow. So borrow 1 from this 2. Okay, so borrow 1, so then we get a 10 here. 10 minus 4 is 6. Next, 9 from 1 doesn't work either, so borrow 1 from the 7, and that becomes a 10, so 10 plus 1 is 11. So 9 from 11, that's 2. Yeah, more borrowing needed. 9 from 6 we can't do, so borrow one last time. 9 from 16 is 7. And 0 from 3 is 3. All right, so that's the same as what's happening over here. So yeah, lots of borrowing needed, but it's, yeah, once we've lined up the decimal points, then yeah, you can just ignore them and just treat this like a whole number subtraction. So 37.26, and yeah, again, check that makes sense. So this is close to 47, this is close to 10. 47 minus 10 is 37. So yeah, the answer should be close to 37. Example 3, what's the sum of 9.4, 28, and 0.306? All right, well, yeah, 2 decimals and a whole number. Okay, but yeah, every whole number, you can think of it as a decimal. So as we saw before, the decimal point always goes to the right of the ones place. So it's 28 point. Yeah, not the decimal point doesn't go in front of the 2, it goes to the right of the 8. So you could write this as 28.0 or 28.000, right? This last decimal has 3 places, so we can give all of these 3 places. Okay, so adding those insignificant zeros, it doesn't change the value of the numbers yet. This is still 28. All right, and then line up these 3, and yeah, this is easy. 6, 0, 7. The decimal point gets lined up. 9 plus 8 is 17. Carry the 1. 3. All right, so the main moral of this section is line up the decimal points. All right, here's another subtraction, but this one's more confusing. Example 4, compute 1.8 minus 5.362. All right, so yeah, without thinking, you maybe write this 1.8 minus 5.362. Yeah, the problem here is that the bottom number is too big. So you could start subtracting, but when you get to 1 minus 5, that's no good. You'd like to borrow, but there's nothing to borrow, so okay, we can't do it this way. All right, so yeah, this is more like that section we looked at. These sections 2.3 and 2.4, adding and subtracting sign numbers. Okay, so let's remember how that worked. Okay, so 1.8 minus 5.362. We can always think of a subtraction. So subtracting a number, it's the same as adding its opposite. Okay, so this is a good way to do this problem. So it's 1.8 plus negative 5.362. Okay, and then we had a rule how to handle adding two sign numbers. So if you remember, this is section 2.3. So to add two sign numbers, well, yeah, the second case, if they have different signs, then you subtract the smaller absolute value from the larger absolute value, and the answer has the same sign as the number with the larger absolute value. Yeah, it's kind of complicated. So the absolute value of 1.8 is just 1.8. The absolute value of negative 5.362 is positive 5.362. Yeah, we can see this is the larger absolute value, and it corresponds to the negative number. So that just tells us that the answer is going to be negative, the final answer. And the actual calculation, well, it's the larger absolute value minus the smaller absolute value. Okay, so it's really, yeah, we need to put this 5.362 on the top and subtract the 1.8 and make that 1.800. Yeah, 0 from 2 is 2, 0 from 6 is 6, 8 from 3 doesn't work, borrow a 1, 8 from 13 is 5, and 1 from the 4 now, that's 3. Okay, so we're subtracting the smaller absolute value from the larger. We get this number, and then we have to use the sign of the number with the larger absolute value. So the answer is negative. All right, and this, again, yeah, this should make sense. If you're at 1.8 on the number line, and then you go left 5 point dot dot dot, you're going to end up in negative territory. All right, so we're using our rules for adding sign numbers. Yeah, they certainly work for fractions, mixed numbers, decimals. So again, this is a good review. So if you're subtracting a number, that's the same as adding the opposite. Okay, so keep this one, change this to a positive, to a plus, change this to the opposite. And then we have rules for adding sign numbers. So if you're adding two numbers with the same sign, you add the absolute values and keep the sign. Adding two numbers with different absolute values, you subtract the absolute value, the smaller absolute value from the larger, and use the sign of the number with the bigger absolute value. Okay, so it's complicated, but hopefully you're getting used to it with practice. Yeah, there's more examples in the book. Yeah, so the same idea. When you're adding decimals, just make sure you line up the decimal points, and yeah, include insignificant zeros to give them the same number of places, and then just add in the usual way, and the decimal points line up. Yeah, here are 4 numbers. Yeah, so that including the zeros is optional. Just yeah, if there's a space, that means 0. Okay, how about this one? Find the difference 50 minus 4.706. Yeah, so the 50 goes on top. Yeah, so we could just do this as a direct subtraction, since we're subtracting a smaller number. If you're subtracting a bigger number, that's where we had the issue in the last example. Yeah, the only issue in this example is we have to do some borrowing. A common mistake here is to say, well, 0 minus or 0 from 6 is 6. But yeah, you see I did that the wrong way around. It's really 6 from 0, which you can't do. 0 is too small. So we have to borrow, but there's nothing here. Okay, we have to go all the way over here to the 5 to borrow. So borrow 1 from the 5, that's really 5 tens. So that gives us 10 here. Borrow 1 of these. We're left with 9. That gives us 10 tenths. Borrow 1 of those. That's 10 hundredths. Borrow 1 of those. And that's 10 thousandths. All right, yeah, so it's clearer down here. Yeah, we're just rewriting 50 as 49.99 plus 10 thousandths. All right, so with that borrowing, now we can do the subtraction. 10 minus 6 is 4. 9 minus 0 is 9. 9 minus 7 is 2. 5, 4. Yeah. So just one borrowing needed. And yeah, this is one of those questions where you could maybe a good idea to check your answer. So if you so this looks like the answer. You can check it if you add that 4.706 back onto this. You can check that you get 50. And this example here, if you're adding a bunch of positive and negative numbers, then yeah, it's a good idea to add the negative numbers together, add the positive numbers together. And that's these ones. And then separately add the negative numbers. Okay, so adding these negative numbers with the same sign, the answer, you keep the sign. Okay, so you end up with a positive number plus a negative number. And then do that at the end. All right, so yeah, so doing these by hand is a lot of work. Yeah, certainly easier on a calculator, but At least for now, yeah, we want to do everything by hand. And of course, yeah, an application to money, yep, prices, adding up bills. So yeah, you can certainly doing accountancy. You're adding decimals and subtracting. Okay, so for adding and subtracting, yep, just line up the decimal points. The next section, let's look at multiplying and dividing. But for now, just kind of an easy case, multiplying and dividing decimals by tens and powers of 10. So we know how to multiply a whole number by 10. It's very easy. So 76, for example, times 10. Well, you just add a 0 on the right. So 76 times 10 is 760. And we can see what happens. So yeah, remember our one way to think about whole numbers and decimals is to see what each digit represents. Okay, so starting with that 76, that 6 represents ones, and the 7 represents tens. Now, if you multiply six ones by 10, you get 60. So when you're multiplying by 10, the 6 moves from the ones to the tens place. And also the 7 moved from the tens place to the hundreds place. Okay, so remember our place system. So we have ones, tens, hundreds, thousands. Every time you move left, you're in a place that represents numbers 10 times bigger. All right, so that's why multiplying by 10 is so easy. You're really just kind of shifting the digits into higher value places. And the nice thing is, yeah, exactly the same thing happens with decimals. So let's say you want to multiply this decimal, 76.54, by 10. Yeah, so we can see here, yeah, so the digit to the right of the decimal point, that represents tenths. So it's 5 tenths. Here we have 4 hundredths. What happens if you multiply 4 hundredths by 10? Well, you get 40 hundredths, or 4 tenths. Okay, so multiply that 4 hundredths by 10, you end up with 4 tenths. Okay, so the same thing happened. It moved from the hundredths column to the tenths column. The 5 tenths becomes 5 ones. The 6 ones become 6 tens, and the 7 tens become 7 hundreds. All right, so yeah, when you break it up into pieces, it's really just you're adding these together: 4 hundredths plus 5 tenths plus 6 ones plus 7 tens, and then when you multiply each of those by 10, they just move into the next column. All right, so when we multiply decimals, do we have to move each change hundredths to tenths and tenths to ones, tens to hundreds. No, there's an easier way to do it. Just move the decimal point one place to the right. All right, so yeah, this is really nice. So this is why it's true, but so 76.54 multiplied by 10 is equal to 765.4. Okay, so the decimal point just moved one place to the right. Of course, yeah, when you multiply a number by 10, you expect it to get bigger, 10 times bigger. So roughly 76 turned into 760. But yeah, it's really 76.54. When you multiply by 10, turns into 765.4. Okay, and you can see what would happen if you multiplied 76.54 by 100. Well, that's 10 times 10, so you just be moving the decimal point 2 places to the right. Example 5, find 0.04921 multiplied by 1,000. Yeah, we see 3 zeros here, so this is 10 times 10 times 10, or 10 to the power 3. Okay, so multiplying by 1,000 means moving the decimal point 3 places to the right. So if it starts out here, it's going to end up between the 9 and the 2. So we get 0049.21. And now, these zeros have become insignificant. So they're to the left of the whole number part now. Well, this is insignificant, but this second zero is significant up here, but it's when we move the decimal point, these are both insignificant now, so simplify this to just 49.21. All right, so just if you're multiplying by a power of 10, just figure out which power it is, how many tens, and then move the decimal point 1, 2, 3 places here. And sometimes, you can simplify your answer. Yeah, this is correct, but this looks better. Example 6, find 3.8 times 10 to the power 4. Okay, so we know what we want to do. We want to move that decimal point 4 places to the right. But what happens here? There's no place to move it to. Well, yeah, just don't forget, you can always add insignificant zeros. Here we're adding them to the right of the fraction part, so that's okay. So you could add a bunch of zeros, but yeah, we only need 3. Okay, so 3.8 is equal to 3.8000. And now we can move that decimal point to here. And we end up, you could have added more zeros, it doesn't matter. But the decimal point has to go here. And then, then you can simplify this. It's just a whole number, 38,000. So this, any extra zeros here are insignificant. Okay, so this 3.8, we multiplied it by 10 to the 4. That's really 10,000. So it became 10,000 times bigger. And we got 38,000. Yeah, that makes sense. So, yeah. All right, so we've seen, the rule is very simple. So to multiply a decimal by a power of 10 here, 10 to the power n, you just move the decimal point n places to the right. Okay, so when you're multiplying by a power of 10, here we're talking about positive powers of 10. You're moving the decimal point to the right. Okay, of course, dividing, that's the opposite of multiplying. So if you divide by a power of 10, that's also easy. Just the decimal point is going to move in the opposite direction, to the left. So to divide the decimal by 10 to the power n, just move the decimal point n places left. So dividing, you go left. If you're dividing by 10 or a power of 10, your number is getting smaller, so make sure you end up with a smaller number, not bigger, or you've gone in the wrong direction. Example 7, find 3.8 divided by 10 to the power 4. Okay, so the operation is division now. So if we were multiplying by 10, we'd move the decimal point to the right 4 places, but now we're dividing, and so it has to go left. Add some insignificant zeros, this time to the left of the whole number part, and then move it 4 places. We get this. So 0.00038. This first zero is not strictly necessary, but usually we write it. Okay, so 3.8 divided by 10 to the power 4. So we're making this number 10,000 times smaller this time. So we get this small decimal. So like I was saying, it is confusing knowing when to move the decimal point left and right, but just remember bigger and smaller. Multiplying by powers of 10, you want the number to get bigger. Dividing by powers of 10, it should be getting smaller. So this is the same rules. So to multiply the decimal by 10 to the power n, move the decimal point n places to the right. Dividing by 10 to the n places to the left. Okay, so these examples, 623 divided by 10. So the decimal point starting out here, dividing by 10, it has to move to the left one place. So 62.3. Dividing by 100, it has to move left 2 places. So add some more zeros at the front, and you get this. And yeah, 480, again, the decimal point is here, and it moves one place here, so we get 48.0, which is just 48. Yeah, you could combine this with our with sign numbers. So yeah, if you're dividing two sign numbers, the answer is negative if they have different signs, positive if they have the same signs, but here they're different signs, so the answer is negative. And then do the division separately, so 3.738 divided by 100 is the decimal point moving left 2 places. We get this, and it's negative. Yeah, so maybe confusingly, we have looked at this before. We looked at this last time. Negative powers, for example, negative powers of 10 mean reciprocals. So yeah, so another way to think about, say, yeah, dividing by 100, that's the same as multiplying by 1 over 100. Okay, if you remember when we looked at reciprocals. So another way to think about dividing by 100 is multiplying by 10 to the power negative 2. Yes, so for example, yeah, dividing by 10 is the same as multiplying by 1/10, or 10 to the power negative 1. But yeah, so negative powers, yeah, they don't mean negative numbers, they mean reciprocals. That's the main idea. All right, and this is the last section. Okay, so we've just looked at multiplying decimals by powers of 10. Now we want to be able to multiply just any two decimals. So let's see an example. How do you multiply these two guys, 2.3 and 0.05? Well, one thing we can do, I mean, we know what these decimals mean. They're really mixed numbers. So 2.3, so the whole number part is 2, and this 3 represents 3/10. So 2.3 is a mixed number. It's 2 and 3/10. 0.05, that's really 5/100. All right, so we want to multiply this mixed number by this fraction. And yes, so multiplying mixed numbers, we have to convert them to improper fractions. 2 times 10 plus 3 is 23, so this 2 and 3/10 is the same as 23 over 10. So multiplying these two is the same as multiplying these two fractions. Yeah, that's what we're saying here. And how do we multiply fractions? Just go straight across. So on the top, it's 23 times 5. I worked that out here. That's 115. On the bottom, it's 10 times 100. Okay, that's 1,000. So yeah, so for these decimals, yeah, they always have tens or powers of 10 on the bottom. So when you're multiplying powers of 10, so 10 to the power 1 times 10 to the power 2, remember the rules for exponents, it's 10 to the power 1 plus 2, so 10 to the power 3. All right, so that's the answer as a fraction, and we could convert that back to a decimal. So we need we have 10 to the power 3 on the bottom, so we need three places. So that's 0.115. All right, yeah, that was complicated. Can we do this question without using mixed numbers and fractions? The good news is yes. So here it is again. So yeah, so we're multiplying 2.3 by 0.05. The first step is count the places. So we have one place in that first decimal, two places in the second decimal, and then just add those places. 1 plus 2 is 3. So we want the answer to have 3 places. Okay, now we've figured out the decimal point. Now we can ignore it. So now just think of this as just 23. Ignore this, think of this as just 5, and then multiply those whole numbers. So 23 times 5 is 115. Okay, so 115, give it 3 places. So the answer is 0.115. All right, so that gives us our rule. So to multiply 2 decimals, first add the number of places, and then the answer is going to have that number of places. And then ignore the decimal points and just multiply the decimals as if they were whole numbers. Okay, so get this whole number and then give it the right number of places. All right, and yeah, so again, we can see why it works. Yeah, so when you convert the decimals to fractions, you've got a whole number on the top and a power of 10 on the bottom. So you're multiplying those whole number numerators. And on the bottom, if you have one place, that means there's a 10 on the 10 to the power 1 on the bottom. If you have 2 places, that's 10 to the power 2. And then when you multiply those powers of 10, you're really adding the exponents. So that's why we're adding here. So add the number of places in the 2 decimals you're multiplying and give the answer that number of places. Okay, so we're adding the number of places. We're not multiplying the number of places. All right, so one more example here. Example 8, compute 0.064 times 0.09. Okay, we'll do the places step first. This is easy. So this guy has 3 places. This guy has 2 places. 3 plus 2 is 5. So the answer is going to have 5 places. Then multiply the decimals as if they were whole numbers. So think of this as 64. This is 9. 64 times 9 is 576. That looks good. And then, so how do you give 576 5 places? Yeah, I mean, you can think of this as, if this was a whole number, the decimal point would be here. But to give it 5 places, we need some extra zeros. So the decimal point ends up here. Okay, so here's the 576. We've given it 5 places, so this is the answer, 0.00576. Okay, yeah, so this is different from when we were adding and subtracting decimals, we were lining up the places. Yeah, there's no lining up places here. Yeah, you have to count the places, add them up, and give the answer that number of places, right? So it's a different, certainly a different method for multiplying. You're not lining up decimal points. Okay, so again, to multiply 2 decimals, look at the number of places each of them have, add up those places, multiply decimals as if they were whole numbers, and then give it the correct number of places at the end. Yeah, this is what I was saying in general. If you multiply 2 powers of 10 together, you just add the powers, and that's why we're adding places. Okay, the same rule. Okay, so this example, 21.02 times 0.004. Okay, here we have 2 places, here we have 3 places, so the answer should have 2 plus 3, 5 places. And if you multiply the whole number, and so treat these like whole numbers, yeah, so this is just 4. This is 2,102 if you ignore the decimal point. And yeah, when you multiply these, you get 8,408. And so that's the whole number answer, but we need to give it 5 places. So here it is with 5 places. Here's a signed version. So yeah, the only difference here is we have a positive times a negative, so the answer will have to be negative. Okay, so once you worked out the sign, then you can, the sign of the answer, then you can ignore the sign. So 6.30 times 2.05. We have 2 places here, 2 places here, so the answer should have 4 places. Okay, and then we're multiplying 630 by 205. Okay, so do this carefully. 5 times 0 is 0. 5 times 3 is 15. Write down the 5, carry the 1. 5 times 6 is 30, plus the 1 is 31. That's the first row. The second row starts under the 5, but it's just everything times 0, so really the second row is a bunch of zeros. And then multiply by the 2, so okay, now we have to start in the hundreds place. 2 times 0 is 0. 2 times 3 is 6. 2 times 6 is 12. And then add these together. All right, so we get this whole number. We have to give it, what was it, 4 places? So 1, 2, 3, 4. Oops. So the decimal point yet goes here between the 2 and the 9. Yeah, we can also see here that this 0 is now insignificant, so we can simplify. And the answer was supposed to be negative, so don't forget that negative sign. Yeah, so that's the answer. All right.